This video is going to cover section 4 of your Unit 11 flipbook, section 4. We have done this section in class, but for those of you who either need a refresher or maybe you were absent that day and need to go through these sections, this video is for you. Alright, our essential question in this section is, how do I design a parabola for my hot dog cooker and then find the focus? So what we're going to be doing is showing you the steps or giving you an idea how you actually can take a known width and a known height of a parabola, find the equation that fits that area, and then determine what the p-value is, and from that the focus. So the question is, decide how wide and tall you want your parabola to be. When you're building your solar cooker, you're going to have to decide what your width and height is going to be in centimeters. So for the example that we're going to do, we're going to go ahead and select that for you. So let's just say that you want the width of your cooker to be 24 centimeters and you want your height to be 10 centimeters. So how do we go about doing that? Now class, you already have the skills to do this. We just need to see them all put together in sequence. Some things you've learned in previous units and some things you've learned in this unit. Before we go any further, I just want to show you that when you're going to build the parabola for a known area, normally you're going to use the bottom of your graph area and call that the x-axis. We'll build our parabola all above that. So let's call that the x-axis. And then just to make this graph a little bit simpler, let's divide it somewhere in half. It's going to be about right here. So pick a spot right in the middle of your graph area and let's divide that in half, and we'll call that our y-axis. Okay, now to make this an easy problem, we're going to use the vertex, or put the vertex at 0, 0. So over here on the bottom, you're going to label this as your vertex, and let's say that is at point 0, 0. And you'll see when we build the equation of this parabola, it's a whole lot easier when the vertex is at 0, 0. Alright, now we know that our height is going to be 10 centimeters and our width is going to be 24 centimeters, but we want the y-axis to be the axis of symmetry. And that means half of our parabola is going to end up on the right side and half is going to end up on the left. So we should take 24 and divide it by 2, and we're going to end up with 12 centimeters on the right side and 12 on the left. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at this point, 12, that's going to be the far right edge of our parabola. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At negative 12, that's going to be our far left edge. Now we know the height's going to be 10 centimeters. We can count 10 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that point, class, is at 12, 10. Now we know that point is going to be on our parabola because that's the farthest right and highest point of our parabola. And then we can go to the other side also and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can put a point there, and that point is also going to be on our parabola, but that's negative 12 and 10. Negative 12, 10. Those 2 points are known points on our parabola. The vertex is a known point on our parabola. What we don't know is all the points that go in between. Okay, so we're done with the graph so far. Some have asked me, Mr. Z, why don't you divide the 10 by 2 also? Because, class, we don't want 5 units of our parabola to be above the x-axis and 5 to be below. We want all of them to be above the x-axis. We just divided the 24 so we can split the parabola on the center or on the axis of symmetry. Okay, so let's continue with the questions as we work through this problem. Question number 2, we need to find the equation of this parabola. Well, when you want to find the equation of a parabola, you will typically always use the vertex form. Y equals a times x minus h squared plus k. Now to find the equation, all we need are 2 pieces of information, the vertex and a known point on the parabola. Well, the good news is we know the vertex. The vertex is at 0, 0. And that means, class, that we know that h equals 0 and k equals 0. So make a little note for yourself, because we know that this value, the x value of the vertex, is h, and the y value is k. So we know h, we know k. Now we have to find y, a, or x in order to solve or finish this equation. Well, I don't know what a is, but I do have a known point on the parabola. So we're going to go ahead and write here. We have a known point. From that known point, class, we can get a valid x and y value. And take a look. We have two known points. 12, 10 is going to be on our parabola at the top right corner, and negative 12, 10 is going to be at our parabola at the top left corner. Now I'm going to pick this point, and the reason why is because it's positive numbers, and I don't want to deal with the negative number if I don't have to. This is our x value, and this is our y value, and I'm going to go ahead and write here, just put on our graph, that's h, and that's k. Okay, so that point is 12, 10, and we know from this that x is equal to 12 and y is equal to 10. So now look at our vertex form. We know y, we know x, we know h, we know k. We can plug all those in and solve for the variable a. So let's do that. We've got y is 10, so we're going to replace y with 10. A we don't know. X we know is 12 minus h, which is 0 squared, plus k, which is 0. Hey, we've got an equation with one variable, which is the letter a. We can always solve a variable if it's the only one in an equation. So let's go ahead and do that. I'm going to change colors as we go so you guys can see me working. This is 10 equals a. 12 minus 0 is just 12, so that's going to be 12 squared. We don't have to put the plus 1 because that doesn't do anything to change our equation. All right, let's do the next step. 10 equals, well, 12 squared is 144. I'm going to put the a at the end, so I'm writing it in proper math language. And now you can see, class, we can divide both sides by 144, and that will get a by itself. So we're going to divide both sides by 144. Let's do that. We know a is going to be equal to some estimate. Let's go ahead and put this in our calculator. So we got 10 divided by 144. And that equals 0.0694. We're going to round this to 4 decimals. So 0.0694. I don't like that first 0. Let's fix that. Oops, let's just fix the whole thing, I guess. So there's our a value. Well, now that we have our a value, let's rewrite our equation with the a in there, with the h in there, with the k in there, and that will give us our final equation for the parabola. So y equals a, which is 0.0694. Now x is going to be x minus 0. H is 0. So we can just write x squared. The same as x minus 0 squared or x plus 0 squared. And then the k value is 0. We don't have to write that at all. In class, here is our equation for the parabola that we want. So we found the equation. Let's see what the next step is. Number 3, make an xy table of points on the parabola using positive x values and plot the points on the graph. So all we're doing in the next step is we're going to fill out these points here so we can get a perfect curve for our parabola for our solar cooker. Alright, so here we go. We got to go quick on this. Now I know that at x equals 0, I know that y is going to be equal to 0. Let's put in some numbers here. X is 1, 2, 3, 4, 5, 6, 7. If you look at this, class, we need to get all the way to 12. That's the highest x value we need. So 9, 10, 11, 12. All right. And the way you find the y values is you will plug these x values into your equation. I'm going to do the first couple of them on the calculator. so you can see the process. So we're going to type in 0.0694 parentheses 1 close parentheses, and then we're going to square that and press equal. 0.0694, we're going to round that, class, to 1 decimal because that's as accurate as I can graph, to 1 decimal. So that's going to be 0.1. So our first one is 0.1. Let's put 2 in. Same thing, 0.0694 parenthesis 2 close parenthesis raised to the power of 2, or square it. And we've got 0.27. We're going to round that to 0.3. Now you go through all these points, class, and write in all these values. Now I'm going to show the numbers to you now, but you should check a couple of them just to make sure you feel confident that you can do this. This is going to be 2.5. This is 3.4, 4.4, 5.6, 6.9, 8.4, and at 12 we get exactly, actually rounded to 10, which makes sense. When we plug in 12, we better get 10 because that was the point we were projecting is on our parabola. Alright, now we have to plot these points. So what we should be doing is go back to our graph and look at our table. Let's plot our points as accurately as we can. So at 1 we're going to be at about 0.1, that's almost on the very bottom. At 2 we're at 0.3, at 3 we're at 0.6, at 4 we're at 1.1, 5 we're at 1.7, 6 we're at 2.5, 7 we're at 3.4, 8 we're at 4.4, 9 we're at 5.6, 10 we're at 6.9, 7 we're at 8.4, which is about right here. And you can see now these dots put together make a nice parabolic shape. So we've plotted those points. Now it says reflect these points on the left side of the axis of symmetry. Well, class, I want you to do that. I'm going to pause the video and let you do that, and then you can come back and check my work. So pause the video and go ahead and put those points on the other side of the x-axis. Okay, we're back. Hopefully you've been able to draw those points and make a nice reflection on the other side of the y-axis. And now at this point, class, after you make the reflection, carefully sketch the parabola. So I suggest you turn the parabola upside down and make a nice curve through these points. Make it as precise as you can. I'm not going to try to do it on this video because I can't do that with a writing tablet. Very easy. Okay, now the next step is number 6. Find the focus and plot it on the graph. Well, we know that we can find the focus by finding the p-value. And we know that the p-value is equal to 1 over 4 times a. So it's 1 over 4 times 0.0694. Let's put that in our calculator. Okay, let's move it over here. All right, we got 1 divided by parenthesis 4 times 0.0694 close parentheses, press equal, and we get 3.60. I'm going to round that to 3.6 centimeters. So let's mark our focus on our graph. We go 1, 2, 3.6 right here. And that, class, I want you to label it. That is your focus. Let's write the coordinates of that. 0, 3.6. And now we've written our focus on there. Let's see if we have any other thing to do. Draw a horizontal line connecting the two ends of the parabola. The reason I have you do that is it makes it easier for me to cut this thing out when I'm done. So if you do this, when you're done, sorry. So when you get this done, draw a horizontal line between the two endpoints. And that way we can easily cut this parabola out. You'll already have this curve drawn, and that is how you find the equation and find the focus of a parabola with the known width and known height.